Right, everyone, we're going to get into the exciting world of statistical terms and how that works when we are doing things with testing and scatter plots and correlation coefficients and all these very, very exciting things. As a school counselor, honestly, you are not going to be creating tests or using a whole lot of tests, except for maybe you work with standardized testing throughout the year. But I want you to be able to know all of this stuff so that you will understand statistical concepts when you're looking at data and different things with your advisory team as a school counselor. So let's get into it. Today, we're going to talk about test worthiness. So what is test worthiness? There's 4 parts to it. One is validity. Does the test measure what it says it's going to do? The next is reliability. So is what score or whatever the individual gets on a test, is that going to be an accurate measure of their true score? Cross-cultural fairness. Can I give this test to a whole bunch of people in a whole bunch of different places from a whole bunch of different socioeconomic groups? And are those scores going to be the same? Is it going to reflect what it needs to reflect? And then is it practical? So let's say that we had some second graders and we were going to do a 4-hour test with them. That's not practical because they're going to lose interest over a period of time, like maybe 30 minutes. So we need to look at that as well. But the first thing that we have to understand is our friend, the correlation coefficient. Okay, so the correlation coefficient shows a relationship between 2 sets of scores, and it has a range. It's from -1 to +1. So that sounds super mathematical. So let's make it a little bit easier. Let's say that you have 2 friends, and you notice that when one friend is happy, the other friend is usually happy too. So a correlation coefficient is a number that tells you how much one thing is connected to another. So in this case, with our friends, with their happiness numbers, a correlation coefficient would help you understand how closely those happiness numbers go together. So if you have a friend that has, when their happiness goes up, their friend's happiness goes up, that's a positive correlation, which we would call a +1. But let's say that we had a situation where when one friend's happiness goes up, the other friend's happiness goes down. That is going to be a -1 or a negative correlation. So it has to do with how up and down those are. Now, sometimes you may have 2 friends and it doesn't matter at all if their happiness is both high or if it's low, it doesn't match up with each other. And so that would be a correlation coefficient of 0, meaning there's no connection between their happiness. So let's try it one more time. Okay, so let's pretend like we are super detectives and we want to see how 2 sets of numbers move together to see if there's a connection between them. So let's say that I gave you data for 2 things. One of those is ice cream sales and one of those is temperature. So a correlation coefficient is the number that shows us how much the sales of ice cream change when the temperature changes. So if the correlation coefficient is a +1, it means that as the temperature goes up, the ice cream sales also go up. They're best buddies and they're going in the same direction. This is a positive correlation. But if the correlation coefficient is close to -1, it means that as the temperature rises, the ice cream sales go down. It's like they're going in different directions. And this is a negative correlation. Now, in the world that we live in, I would definitely say that the hotter it gets, the more ice cream people buy. So I would be like, yeah, that's a positive correlation right off the bat. But if it wasn't, I would be like, this is really weird. I would probably want to investigate that a little bit more if it was a negative coefficient. But then, of course, if the correlation coefficient was 0, it would mean that no matter what I do, it doesn't seem to, I don't see like a connection between ice cream sales and the sun. So it's like they don't really care about each other at all. And I've not seen that happen. So I think we're good. So here inside your textbook is a very, very exciting chart, and I'll just touch on it for a minute. So here it goes where it's showing positive correlations moving in the same direction. So right here is social connectedness, and as that goes up, your subjective well-being also goes up, or vice versa. If the social connectedness is low, then their well-being may be low as well. But over here, let's take a look at ADHD. This is a negative correlation because often we see that people with ADHD, as that goes up, as it gets higher, their academic achievement will go down, or vice versa. So that over here is a negative correlation where it moves in a negative direction. This is the exciting world of scatter plots. What is a scatter plot? What does that have to do with anything? So let's look at this scatter plot, and it's a big board, okay? And then every student that's in the class has their name written on a point. And so this particular board, it shows us two things. It's showing us GPA and it's showing SAT scores. So from looking at this, I noticed that students have higher SAT scores. If that's higher, then they also tend to have a higher GPA. So if I drew a line right here between these points, it's going to slope upward because it's going to show that when the SAT scores go up, the GPA is going up. So let's look at that on a different type of plot. Okay, so here we have most of these dots, and they are clustered in a way where SAT, let's just say, because I was talking about the other one, the SAT and GRE. Let's pretend that I had drawn the line through those and they were all going up. That would show a positive correlation coefficient, or R, it's called an R, so R equals 1 on that one. And I see the scatter plot is making a slanted line going up from left to right, which shows a positive correlation between SAT scores and GPA. So you just need to remember, as one goes up, the other goes up, and that's a +1. So let's look at another scatter plot here. This is going to be a scatter plot, and it is GPA, and it's also with mixed classes. Now, I'm looking at this, and I'm seeing, okay, it looks like that when a student's GPA is high, the number of missed classes are low. But if it's the other way around, if the GPA is low, then I'm seeing that the number of classes that they miss are going high. So this is a negative correlation because as one thing goes up, the other thing is going down. So in this case, as attendance go down, the GPA tends to decrease. And if I was going to plot that, and I'll bring it over here on my other little plot, I see that going downward. So the slope is going downwards from left to right. And that indicates that as the student attendance in classes decrease, their GPA also is decreasing. So, you know, in simpler terms, when students attend fewer classes, their grades often will go down. So let's look at these fun little plots and see what they might look like. If you have something here where it looks like it's going up, it's not a perfectly straight line, but it looks pretty positive. It's going to be like an R is going to be 0.70. Okay, it's not 1, but it's pretty close to 1. So if we look like over here, we can see, yeah, they're kind of going up together, but not really. They would have a very low R. So this one over here is just R is 0.30. Here's another one right here. Everything is all over the place. Lots and lots of little bitty dots, but I'm not seeing any type of relationship between the two. So here our correlation coefficient is going to be 0.0. So let's look at some negative ones right here. Here on this one, I can see that the line, if I drew a line, it's going to be going down from left down to right. So this is going to be a negative correlation coefficient. So this one right here is R equals negative 0.4. All right, now we have something fun that is called the coefficient of determination. Here's where we kind of get into some math. I probably am not going to overload you, but the coefficient of determination is when we take the correlation coefficient that we just talked to, and we square it, it's going to give you the coefficient of determination, which is the shared variance between two variables. All right, so let's look at the coefficient of determination in some easier terms. So let's think that you have two things. And in this case, we are going to say the amount of time you spend studying for a test and your test scores. The coefficient of determination is like a score that tells you how well one thing, in this instance study time, predicts or explains the other thing, which are test scores. If the coefficient of determination is like 0.8 or 80%, it means that 80% of the time, how well you score on tests can be explained by how much time you spend studying. The higher the score, the better one thing can help you guess or understand the other. The remaining 20% in this case might be influenced by other factors like natural ability, different studying methods, or different ways of studying that really doesn't cover time. So the coefficient of determination shows how much one thing influences or explains the change in another thing. Let's take a look at another example. Okay, think of shared variances between scores on a depression test and scores on an anxiety test, like having common interests, like friends that are having common interests with your friend, and how much these interests overlap. Imagine that you and your friend have a lot of similar hobbies that you both enjoy, like playing video games and reading books. The shared variance between you and your friend's hobbies is the part that overlaps. Those are the things that both of you like to do together. You agree on these things about 80% of the time. However, there are some hobbies and interests that don't overlap. One likes race cars and the other likes fashion. That 20% race cars or fashion are that 20%. And that could just be any random things about their other hobbies. So in terms of the tests that we were talking about with depression and anxiety, in terms of the tests, shared variance between scores on a depression test and scores on an anxiety test are similar. So we can say that those tests measure how much the scores overlap or how much common ground that they share. If there's a high shared variance, it means that a significant part of what's being measured in one test, for instance, in our depression test, is also captured or reflected on the other test, the anxiety test. So let's say that the variance is 70% alike and 30% that just kind of doesn't fit into that. It's that overlap. So the 30% that's not quite there is related to other factors. And those could be like job loss or relationship, or if they had a chemical imbalance in the brain. So remember, a high shared variance between scores on depression and anxiety tests indicate that there are common elements between these two aspects of mental health that both tests are capturing. It's like saying a good part of what's being measured in one test, the depression test, is also relevant to what is being measured in the other test, which is anxiety. Next off, let's take a look at validity. Validity is kind of like making sure a key fits in the right lock. When you want to open a specific door, let's say understanding if a test measures what it's supposed to measure, you need the right key, and that's the validity. So if you have a test that's meant to measure math skills, validity is about making sure that the test actually measures a person's math skills and not something else, like their reading ability or their guessing skills. All right, so let's take a look at content validity. Content validity is like making sure all the important ingredients are in your favorite pizza recipe. So for me, it would be lots of cheese and lots of green olives. Some people are not fans of that kind of pizza. But imagine that you have a recipe for a yummy pizza. For the pizza to be just right, you need all of the key ingredients. So you're going to need the dough, the sauce, the cheese, and your favorite toppings. And if any of these are missing, your pizza is not going to taste as good as it should. So similarly, in tests or assessments, content validity means making sure that all the important parts or ingredients of what you want to measure are included. So let's say that you have a test for math skills. To ensure it has good content validity, it needs to cover all the essential areas of math that you're supposed to know. If the test only asks about addition, but doesn't cover subtraction, multiplication, and division, it might not be a valid measure of your overall math skills. So there are several parts to this of the content validity, and I'm going to go through each of those parts. The first one is to survey the domain. This is like deciding what type of pizza you want to make, such as a veggie pizza or a meat lover's pizza, anything that you like. And as you're looking at this whole pizza and thinking about how you're making it, you're going to look at some cookbooks, you might Google some stuff on the internet, and you might see what Gordon Ramsay's doing. So in terms of a test, in test creation, this step involves determining what the test will cover, such as deciding it's a math test that's going to test algebra or geometry, etc. So the team that's going to make the test, they check the books, they check the curriculum, and they talk to the experts when they're planning the test. The second part is content of the test matches the domain. So going back to our pizza, this ensures all ingredients, the dough, the sauce, the cheese, and the topping, match the chosen pizza type. All the ingredients come from where I did the research, from the book, from the internet, from Gordon Ramsay. We've talked to all of them, and I have all the stuff I need. But in terms of test taking, it means the questions in the test specifically relate to the chosen subjects. So if I have a math test, all the questions are going to come from different areas of math. And those math questions are going to come from the stuff that I was looking for in part one, which is like the content, the curriculum, and talking to the experts. Okay, 3 is specific test items match the content. So you're making sure here that in your pizza, each ingredient fits the chosen pizza type. For instance, if we're having a veggie pizza, I need to have a whole lot of fresh vegetables for that. When we're looking at a test that we're going to give someone, this ensures that each question is directly related to the particular aspects of the subject being measured. So for a math test, each question should directly cover specific math topics. And here we come to the fourth part. In analyzing to analyze the relative importance of each objective. So in pizza, this involves deciding the prominence of each ingredient. For instance, if the sauce is particularly important, it should be carefully chosen. Olives to me are the most important, so we should have a whole lot of that on our pizza. But let's take a look if we're doing with a test. This involves assigning importance to different questions or sections. For example, deciding that algebra questions are more important in the test because it is reflected in the curriculum. So we've looked there in the front, we were like, okay, we've seen the curriculum, these things are the most important. And so in the test, we would like to make sure it's reflected there. Now we're taking a look at a different type of validity called face validity. And this is not a real type of content validity. This is just a quick look at the face value of the questions. And sometimes the questions may not seem to measure the content, but they do. Criterion-related validity helps us understand how well a test predicts or relates to a particular criterion or outcome. So let's talk about concurrent validity. There are two parts to the criterion-related validity. Number one is concurrent validity. So let's say that we have a magic crystal ball, and that shows you what's happening right now. Concurrent validity is like using this crystal ball to see if your test is related to the criterion that's happening at the same time. For instance, you're giving a new test to measure how happy people are, and at the same time, you ask those people about their happiness using a well-established survey. If the new survey's test results closely match the results of the established survey, then the new test has good concurrent validity. The next one is predictive validity. And so for this one, let's say that we have a time-traveling device that shows you the future. Predictive validity is like using this device to see if your test can predict what will happen later. For example, you create a test to predict how well students will perform in college, and then you wait to see how these students actually do in college. If the test scores align with their later college performance, the test has good predictive validity. So, concurrent validity is all about seeing how well a test aligns with the current criterion, like using a crystal ball to see the present, while predictive validity is about how well the test can forecast or predict a future outcome, like using a time-traveling device to see what will happen later. Both help determine if a test is accurately measuring what it's supposed to measure at the same time, which is concurrent, or in the future, which is validity. Now we're looking at the standard error of estimate. A practical application of predictive ability is the standard error of estimate. This is a helpful guess range when you're estimating something. Imagine you're trying to predict how well someone might perform in grad school based on their GRE scores, the test that is for admission into graduate school, and their previous GPA from their undergraduate studies. The standard error of estimate in relation to GRE scores and GPA in grad school is like a helpful measure that tells you how accurate your prediction might be about a student's grad school performance based on their GRE scores and their GPA. Let's say that you use the GRE scores and the GPA to predict a student's future performance in grad school. The standard error of estimate helps you understand how much your prediction might differ, on average, from their actual performance in grad school. It gives you an idea of how closely your prediction, using the GRE and the GPA, will match their real performance in graduate school. For example, if it is a standard error of estimate and it's very, very small, It means that using GRE scores and GPA to predict grad school performance is pretty accurate. But if the standard error of estimate is larger, it means your prediction might be less accurate, and there could be more variability or uncertainty in how well GRE scores and GPA predict grad school student success for different students. So the standard error of estimate helps you gauge the typical closeness or distance of your predictions about grad school performance based on GRE scores and GPA from the actual performance of students in grad school. So let me try to make that a little bit easier for you. Imagine that you have a jar of candies and you want to guess how many candies are inside. If you make several guesses, some might be very close to the actual number, and some might be a bit far off. The standard error of estimate is like an average of distance between your guesses and the actual number of candies in the jar. In more technical terms, when you're trying to predict or estimate something, like predicting test scores based on study hours, the standard error of estimate tells you how much your prediction might differ on average from the actual test scores. It gives you an idea of how accurate your predictions are likely to be. So just like your guesses about the number of candies might be close or a bit off, the standard error of estimate helps you understand the average closeness or distance of your predictions from the actual values. And I had to put the little jar of candy on there because when I was in elementary school, they would have this thing all the time where if you guessed how many there were, you would win the candy. And I never won the candy. However, if I had known about this, maybe things would have gone better. False positives and negative. False positive is like predicting that it's going to rain, which is positive, and preparing with an umbrella, but it turns out to be sunny. In predictive validity, a false positive is when your prediction says that something will happen, like a student will perform well in grad school based on their GRE scores and their GPA, but in reality, they don't perform well. A false negative is like predicting that it won't rain, negative, and you leave your umbrella at home, but then it pours down rain. In predictive validity, a false positive is when your prediction says something will happen, like a student's going to perform well in grad school based on their GRE scores and their GPA, but in reality, they don't perform well. In terms of predictive validity, a false negative occurs when your prediction suggests something won't happen, like a student won't perform well in grad school based on their GRE scores and GPA, but in reality, they do perform well. In predictive validity for grad school, a false positive would be wrongly predicting that a student will excel based on their high GRE scores and GPA, but they actually don't perform well. On the other hand, a false negative would be wrongly predicting that a student won't do well in grad school based on their lower GRE scores and GPA, but they actually perform exceptionally. False positives and false negatives are errors that can happen when using a predictive measure like GRE scores and the GPA to foresee future outcomes like the success in grad school. All right, we're moving over into the fun world of construct validity. And construct validity is the extent to which the instrument measures the theoretical or hypothetical trait. Many people, counseling and psychological constructs are complex, ambiguous, and not easily agreed upon, especially when we're looking at things like intelligence, self-esteem, empathy, and some other characteristics. There are 4 methods of gathering evidence for construct validity, and those are experimental design, factor analysis, convergence with other instruments, and discrimination of the other measures. Let's take a look at those. All right, we've got experimental design validity. Imagine that you are a scientist doing a super cool experiment. Experimental design validity is like making sure your experiment is set up in the best way possible so that your results are accurate and reliable. Think of it like building a Lego structure. If you follow the instructions carefully and make sure that every brick is in the right place, your structure will turn out exactly as it should. In an experiment, if you set it up correctly by following certain rules and making sure everything is done properly, your results will be trustworthy and it will be reflecting what you want to study. So experimental design validity is about organizing your experiment in a way that ensures that you're doing everything right, like placing the Lego bricks accurately, so that the final result, like the Lego structure, is a true representation of what you wanted to study. Next up is factor analysis. Factor analysis is like sorting a messy room into different groups based on the types of things lying around. Imagine that your room is messy with toys, books, and clothes scattered all over. If you start grouping similar things together, like toys in one corner, books in another, and clothes in a separate pile, that's a bit like what factor analysis does. In the world of data, factor analysis is a way to organize and group together different pieces of information that seem to be related. It helps to find a pattern in data by identifying which things tend to go together or are linked in some way. For instance, it might be a group together exam scores in math, physics, and chemistry because they are often performed well by the same students. Just like cleaning your room helps you organize and put together similar items, factor analysis helps researchers organize and understand how different variables in a set of data relate to each other. It simplifies complex information by grouping related things together, making it easier to understand the underlying structure of patterns within. Step is convergent validity. Convergent validity is like inviting two friends to a party who always agree to the same thing. They both confirm your belief about a particular thing. In the world of tests and measurements, convergent validity means different tests are supposed to measure the same thing. They should give you similar results. So for example, if you have two tests meant to measure how friendly people are, and both tests consistently show that the same people are very friendly, that's a sign of convergent validity. It's like having two friends who always say the same thing. If they both agree that someone is super friendly, it strengthens your belief that person is indeed super friendly. Similarly, when different tests that are expected to measure the same trait or concept consistently show similar results, it supports the idea that they are converging or coming together to confirm a trait or concept. Discriminant validity. So in this fun example, let's imagine that you have different tools to measure how tall people are. One is a measuring tape and the other is a weighing scale. Discriminant validity is about making sure that these tools are measuring different things. The measuring tape is meant to measure height and the scale is meant to measure weight. Similarly, in testing, discriminant validity ensures that different tests are truly measures of distinct traits or characteristics. For example, one test might measure anxiety, while the other measures happiness. Discriminant validity makes sure that these tests aren't just measuring the same thing in different ways, but are actually distinct and separate in what they assess. Just like a measuring tape measures height and a scale measures weight, different tests should measure different things. Test reliability. Test reliability is like a game where you throw darts at a target. If you throw the darts and they consistently land close together, then I would say your aim is reliable. This is reported as reliability. This is reported as a coefficient. Okay, let me start again. This is reported as a correlation coefficient. Oh, these math words, they get me sometimes. Okay, the closer to R equals 1, the less error there is in the test, and vice versa. In the world of tests, reality means how consistent or dependable a test is in giving the same or similar results when used multiple times. For example, if a test measures your height, a reliable test will give you similar results if you take the test today, tomorrow, or next week. So just like throwing darts, if you have a good aim, your darts will consistently land close together. In testing, a reliable test will consistently produce similar results, showing that it's trustworthy and dependable in measuring whatever it's intended to measure, whether it's height or intelligence or any other trait. Let's look at determining reliability. First off is test-retest reliability. Once again, I'm going to give you a fun example. So let's say that you have a favorite toy car and you want to make sure that it always moves the same distance every time you push it. Retest reliability is like checking if your toy car travels the same distance when you push it multiple times. If each time you push it from the same spot, it moves almost the same distance, then your little car is reliable. In the world of retest reliability means doing the same test on different people at different times and seeing if the results you get are consistent. For instance, if you give a group of students a math test today and then give them the same test a week later, and their scores are very similar, then you would know that that test has good retest reliability. Just like our friend, the toy car, moving the same distance each time, a test with good retest reliability will consistently provide similar results when it is given to the same group of people on different occasions. Here we have alternate, parallel, or equivalent forms reliability. Let's say that you have a favorite storybook and you want to make a copy to see if the words and pictures look the same in both books. Alternative, parallel, or equivalent forms of reliability is like making a duplicate of your storybook to ensure that both books are exactly the same in content and layout. In the world of tests, this concept means creating different versions of the same test that measure the exact same things. For example, you might design two different versions of a math test that have different questions but cover the same math skills. Then you give both versions to a group of students and check if the scores between the two are very similar. Just like making both storybooks and have the same words and pictures, having good alternate, parallel, or equivalent forms of reliability means that ensuring that these different versions of the test measure the same knowledge or the same skills and provide similar results when given to the same group of people. Internal consistency is like making sure all the players in the band are playing in the same tune. So let's say that you went to a band where each musician was playing their own melody. If the band practices and all the musicians start playing the same melody together, that's good internal consistency. In the world of tests and assessments, internal consistency means that all questions in a test are measuring the same thing. If you have a test to measure reading skills and all of the questions on the test are related to reading and comprehension, then that's good internal consistency. Just like the band where all the musicians are in harmony, a test with good internal consistency means that all the questions in the test are related and measure the same concept or skill without causing confusion or distraction. Split half or odd even reliability. Split half or odd even reliability is like making sure your toy box has an equal number of red and blue toys and seeing if both groups of toys are equally fun to play with. In testing, it involves splitting a test into two equal parts to check if both halves are consistent, measuring the same thing. So for split half reliability, imagine that you have a toy box with red and blue toys. You divide the toys into two equal groups, making sure each group has an equal number of red and blue toys. If both groups are equally fun, that's like good split half reliability. Similarly, in testing, if you split a test into two halves and both halves have consistently measured the same thing, then it's good split half reliability. Odd even reliability is like when you have a row of toys where you play with every other toy. If the toys you play with, the odd number toys, are just as fun as the ones you skip, the even number toys, it shows that both sets of toys are equally enjoyable. In testing, odd even reliability involves dividing the questions into two sets. You have odd numbered and you have even numbers, and you see if both sets measure the same thing consistently. So, in split half and odd even reliability are methods used to check if different halves or sets of questions in a test consistently measure the same thing. Just like making sure the sets of toys are equally fun to play with, these reliability methods ensure that different groupings of questions in a test provide consistent and reliable results. Now we have Cronbach's Alpha. This is like a superhero team that checks how well all the questions in the test are measuring in the same thing. If the questions in the test are about the same topic, Cronbach's Alpha helps determine how well they will work together to give a reliable measure. Just like superheroes joining forces, Cronbach's Alpha examines if the questions in a test are all on the same team and measure the same concept or skill. Next is Cooter-Richardson. It's similar, but it's specifically used for tests that have answers that are either right or wrong, like true or false questions or multiple choice questions. It's also like a superhero team, but for tests where you have clear-cut answers. Cooter-Richardson helps ensure that the questions in the test all fit together and reliably measure the same thing only when there are only right answers or wrong answers. Now we have item response theory, or IRT. This is like a special way of understanding how good you are at a specific skill based on the questions you answer in a test. So imagine that you're playing at different levels of a video game. IRT is like figuring out how good you are at the game by looking at how you perform on different levels. Some levels might be harder, and if you do well on those, it shows that you're really skilled. If you struggle on easier levels, it might suggest that you need more practice. Similarly, in testing, IRT looks at how people respond to different questions in a test. It helps to figure out how good someone is at a particular skill by considering the difficulty of the questions they answer correctly. If someone consistently answers difficult questions correctly, it suggests a high level of skill in that area. IRT gives a different understanding of a person's ability by considering not just whether they answer questions right or wrong, but also the difficulty of the questions they answer correctly. This helps understand a true person's skill. Cross-cultural fairness is like making sure that a game is fair for everyone, no matter where they are from or what language they speak. Imagine that you have a game that uses different rules for different players from different countries. Cross-cultural fairness means making sure that all players, no matter where they're from, have an equal chance to play and win the game. It's like ensuring that the rules and conditions are the same for everyone, so nobody is at a disadvantage because of their background or their culture or their height. In the world of tests and assessments, cross-cultural fairness means that a test or assessment should be fair for everyone, regardless of their cultural background, language, or where they come from. It involves creating tests that are unbiased and do not favor or put any specific group at a disadvantage. The questions and the conditions should be understandable and equitable for everyone, regardless of their cultural differences, ensuring a level playing field for everyone. Okay, laws and assessment. Over time, there have been different laws that help make people more equal or be on an equal playing scale. And as a school counselor, these are the ones that you definitely need to know. The first one is the Americans with Disabilities Act. This law states that accommodations must be made for individuals who are taking tests for employment, and that testing must be shown to be relevant for the job in question. The Family Education Rights and Privacy Act, or FERPA, of 1974, which we also call the Buckley Amendment, is a law that affirms the right of all individuals to review their school records, including test scores. So that means that a legal guardian of a child can go into the school and request to look at their private records. The school has 45 days to comply with this. If a parent went in there and felt that something that was in the FERPA file was wrong, maybe a note a teacher had in there or something the counselor had said, they have the right to kind of do a rebuttal and put information into the file that rebuts what was said. The Carl Perkins Act. This law assures that individuals who have disabilities or who are disadvantaged have access to vocational assessment, counseling, and placement. Another important one is the Civil Acts Right of 1974 and the following amendments. These are a series of laws that assert that any test for employment or promotion must be shown to be suitable for the job in question. If not, alternative means of assessment must be provided. Differential test cutoffs are not allowed. The Freedom of Information Act. This law assures the right of individuals to access their federal records, including test records. Most states have expanded this law so that it also applies to state records. The Individuals with Disability Act, which is known as IDEA or IDEA. These legislative acts assure the right of students to be tested at a school system's expense if they are suspected of having a disability that interferes with learning. These laws assert that the school must make accommodations with the least restrictive environment for students with learning disabilities. And this is very, very important for the school counselor, and it's something that you need to know. If parents are noting a problem behaviorally or they are noting a problem academically, they have the right to ask the school to test their child. You as the school counselor know this. People may not want you to use it, but if a parent puts it in writing and requests that their child be tested, they have 30 days, maybe 60 days, depending on the district. I think it's 30 days in which the child is able to be tested. So just kind of let them know that, hey, this is your right and you can follow up on it as you see fit. So Section 504 of the Rehabilitation Act. This is one as a school counselor that you are going to be very involved with. So relative to assessment, any instrument that's used to measure the appropriateness for a program or service must be measuring the individual's ability, and it may not be a reflection of his or her disability. So some students with behavior problems may need a 504 to help them with management of their emotions in the classroom. Another reason you might do a 504 is if a student has broken their arm and they need certain accommodations so that they can be successful in school. All right, practicality. We're getting right to the end. Practicality. These are things that you need to think about before you choose a test. Time, cost, the format, the readability, and the ease of administration, scoring, and interpretation. So like I said at the beginning of this, you would not want to take a second grader and give them something that has a lot of reading on there and has a whole lot of time, like say that it takes them 10 minutes to be able to do that. So when you are selecting and administering a test, even if you are not in a school, but you're in a clinical mental health setting, these are things that you are going to want to do. First, determine your goals of the client. Where are they at? Let's say they're depressed or they're anxious, and you want to kind of measure that to see where they are now so you can kind of look at that over time. So choose an instrument that reached the client's goals. So look for an instrument for depression or for anxiety or any other problem that you're concerned about. Access information on possible instruments, examine their validity, reliability, and cross-cultural fairness, and is it a practical? And then choose wisely. You might say, okay, Dr. Moon, where can I find a good instrument to use? And the places to look for instruments are the Burroughs Mental Measurement Yearbook, known as the MMY. And I'm pretty sure that our library will have a copy of that you can look at. I don't know if it's electronic online, but I know that they will, and it's huge. And you can go through there and find a whole lot of different things. I am an internet girl, so I just search on the internet for different types of tests. So I can look at publisher resources and they can send me catalogs, or I can just look at the different one online. If you get any types of journals in the field, you can definitely use those journals to get information. You can look at books that have testing things in it. So if like a textbook that you have and you're like, oh, this looks interesting. You can talk to an expert, which would be those of us on faculty, or like I said, you can also use the internet. All right, so that is our section on test worthiness. I hope that was helpful for you, and ask me any questions that you may have. I'm happy to answer them.